This is the spreadsheet that is provided as part of the handout. At the end here, we have several tabs. One of them is raw data 0, and then ang1, ang2, etc., and then ang1 example. I'm going to start at the raw data 0. What we have here is similar to what you get from phyphox, from the app phyphox. So we are going to have a column for time, acceleration along the x, acceleration along the y, acceleration along the z, and the overall magnitude of the acceleration, which is square root of this squared plus this squared plus this squared. Now, we are not really interested in all of this data. We are interested in the acceleration that is the acceleration along the side of the phone that is parallel to the incline. For example, if we set up the phone with its long side parallel to the incline, most probably would be using the y acceleration. But just in case your phone is configured differently, we need to make this test at least once. Okay, so what we do, we are going to highlight everything except the magnitude, and we are going to go insert, and then we are going to select scatter. And this is what we get, something like this. So what I want you to do is expand that graph as much as you can so you can see what's in it. Maybe come here, since it goes all the way to 16, we don't need that, and it doesn't look like we have anything interesting here. Maybe you can come here if you don't see things clearly. Actually, let me come here, right click, format axis, and we can tell it to start at 6 and stop at 14, for example. Okay. Now, when we did that, if you notice, we have 3 graphs here. Along the X in blue, along the Y in orange, and then gray along the Z. And you notice only along the Y we have what looks like a constant value for a little bit of time. And actually it's going to be a fraction of a second. And in this case, that's because the phone was set up with its long side parallel to the incline. Now, if you'd like to see the graphs individually, you can do copy and paste. I'm going to undo what I just did. You need to click outside of the graph and paste. I'm going to do it 3 times so we can see all 3 axes. This is a leftover graph that I did before that you are going to find in the spreadsheet, but let me click below the graph and paste. So I have 2 and below the graph and paste. And for this one, I'm going to click here and right click, select data, and I'm going to leave just the X. I'm going to tell it remove that and remove that. Okay, so you see it's kind of what looks like noise somewhat. We click on this one, right click on the data, select data, and we remove the X and the Z. Okay, so I go down to look at it. And you see it looks like this is the portion we are interested in. And then I can click here. Select data and remove everything after Z just to confirm. Okay. And here it looks also red. So that confirms that for this particular data that I collected, the y-axis is the valid one. So what I need to do, I need to come here, highlight this column, if this is my first angle, and come here and paste it here. And then come here, come back here, highlight the y-axis data and paste it here. And you see my data got ported here. Now, in what's happening here, I have three columns. This column here is checking for the value of delta t. That's the time difference between every reading. So it is just taking the difference between successive values. And it looks like it's about the same as 5 milliseconds in this case. Now here, it is calculating t. What we are interested in, because this is the only part that's relevant, the only part where our phone was accelerating, this is probably me holding it. This is the only part that our phone is accelerating, so we want to start the time t equals 0 here. So what this cell here is doing is calculating, is trying to find for us when should we start t equals 0. And this one here, it would just transfer the data from here to here for that particular time. Okay, now how is this done? So what we do, we put our angle here. In this case, I had an angle of 30 degrees. It will calculate for us what we expect for the acceleration. That's the equation that's in the handout, based on that angle. Now, what I'm setting here, what I'm calling minimum threshold and maximum threshold. So this is going to check on the acceleration. It's going to check if the acceleration is between that minimum and that maximum. If it is outside those values, it's not going to show it here in this column. Okay, so how does this work? This threshold is a percentage. So minimum A is going to be 70% of this value in this case. And the maximum A it's going to allow in, it's going to be 120% of that value. So if I scroll here, empty, 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 so it's empty for quite a while. And there it is. I highlighted it already. Okay, this is when the acceleration is within that range. This is within the 70%. So the time starts at 0 and it keeps on increasing. And we have a little bit less than 1 second of that. Actually, it is 0.22 seconds. We have other times afterwards where we are within that range, but we are ignoring them. We are just keeping the part that's consecutive. So that's my relevant data. That's the data that I'm going to use to get the acceleration that I need in here for that particular angle. In this case, I would write 30 degrees. I'm going to write my uncertainty in measuring that angle, and that acceleration, a sub y or whatever it is, it does not matter the label here, and the uncertainty in the acceleration. And how do I get the acceleration? Okay, so I'm going to look at this data here. So we are in cell 1321. Okay, so I'm going to come here. I'm going to calculate the average. And I'm going to come here all the way to cell 13 something. And get that average. So that should be the acceleration for that angle. And for the uncertainty in the acceleration, delta acceleration, what I need to do, probably it's easier to just highlight it like this and come here, paste it, so I need to make sure that I'm getting the exact same data, and then change that to the standard deviation equation. And this would be my uncertainty in that acceleration. Acceleration, uncertainty in the acceleration. Okay, I'm done with that angle. And then I do the similar thing for angle 2, 3, 4, 5, and port the data here and do the graph I need to do, etc. And get the line S to use the line S to get G from this graph that I make here. In the example here, I show the actual calculation already done. Okay, so it is done. I have the data in there, and I have the graph, and I have the acceleration. Let me write it down so it will be for you when you look at this. That's all.